In this video, we will be going through the commonly missed questions from each of the Quia assignments from 413 through 417. Our first assignment was the Unit 8 Notes video Part 1. For question 4, convert the following word equation into a skeleton equation. Carbon monoxide gas plus oxygen gas makes carbon dioxide. Now we know from the prefix of mono here that there is going to be a single carbon and a single oxygen, and it is gas. That eliminates two of our choices. So we know it's not either of these equations because they are starting with carbon dioxide. Plus oxygen gas. Oxygen is O, but oxygen is also a diatomic, so it needs a little 2 here. So that eliminates this third choice. And of course, we are making carbon dioxide gas. Number 5. In order to balance a chemical equation, we must alter the subscripts on both sides of the arrow so that the total number of atoms matches. Now, you're actually not allowed to change the subscripts, so this would be false. Changing the subscripts would be equivalent to changing these numbers down here, which changes the identity of the actual compound. So the only way that you could balance an equation is by placing numbers out in front of the molecule, and those are called coefficients, not subscripts. All right, next up we have Unit 8.1, which is the skeleton equation practice number 1. We're given a sentence and we need to convert this into a skeleton equation. We're starting off with aluminum bromide, and it's a solid. We have aluminum, which is a +3, and bromine, which is a -1. Remember, for ionic compounds, you need to crisscross the charges, and that was the biggest error that I saw throughout this assignment. So the 1 is going to cross down to the aluminum, the 3 is going to cross down to the bromine. I'm going to put the final answer down here. So we have AlBr3, and we were told that this was a solid. The aluminum bromide reacts with chlorine gas. Chlorine gas is going to be a diatomic element, so Cl2, and G for gas. It is going to form solid aluminum chloride. So again, I have a compound. I'm going to need to crisscross the charges here. So I have Al +3, chloride is chlorine, so Cl -1, and those are going to crisscross down. So I end up with Al, Cl3, and they told us that that was a solid. We are also making bromine gas, so plus Br2, and that's going to be a gas. The 2 is here because bromine is also a diatomic element, just like the chlorine. Now, for these equations on this assignment, we were not supposed to balance anything, so you should not have any coefficients out in front. We're just writing the skeleton equation, which is not balanced. Next, we have aluminum metal. Now, I noticed for a few people they put in M in parentheses. If it's a metal, we know that it's going to be a solid at room temperature, with the exception of mercury. And since mercury is not present, we don't have to worry about that. We have hydrochloric acid. Now, since we haven't covered how to name acids yet, I just gave you what that formula was. So that's HCl. It is reacting to form, so that's where my arrow is going to be. Aqueous aluminum chloride. We had the aluminum chloride up here, but again, we have the Al +3, the Cl -1. Those are crisscrossing down, so I end up with AlCl3. This time it says that it's aqueous. So AQ, we have a different phase of matter, plus hydrogen gas. So it's going to be H2 and then a J. For our next question, we have solid calcium hydroxide, and it is added to phosphoric acid. The calcium hydroxide, we have Ca with a +2 charge, OH with a -1 charge, and we're crisscrossing those down. Now, after I do this, that hydroxide is a polyatomic ion, so it needs to be in parentheses. So I have CaOH2, and they told me that that was a solid. It is added to phosphoric acid. Again, I haven't taught you how to name acids yet, so I'm just giving you the formula. So it's H3PO4. It says the phosphoric acid is dissolved in water. That means that it is AQ. And actually, I forgot that for up here in number 5. that hydrochloric acid was also dissolved in water, so that really should have an AQ for the phase of matter as well. This reacts to form solid calcium phosphate. So calcium has a +2. Phosphate is PO4 with a -3 charge. After I crisscross those down, I'm going to have Ca3, PO4 in a parentheses with a 2 outside. It says that's solid, so I'm going to have an S here. And then I also have water, which you know is a liquid at room temperature. All right, so just in general, when I was looking over the results for this assignment, the biggest issues were not crossing charges correctly, not listing the diatomics as having the little 2 when they're by themselves, and either forgetting the phase of matter or including the wrong symbol for the phase of matter. So if you got a few wrong on that assignment, that could have been what you were doing. For these skeleton equation assignments, I did have the correct answers pop up upon submission. So if you want, you could take another look at that and see exactly why your formatting might have been off. The next assignment was Unit 8.2, so the same kind of thing. We're starting off with this first one. We have zinc metal. That's going to be zinc. It's a metal, so that's a solid at room temperature. It's reacting with copper 2 nitrate. So that's going to be Cu with a +2 charge, NO3 with a -1 charge, and those are going to crisscross down. So that ends up being Cu, NO3 2, and that is aqueous. We are forming aqueous zinc nitrate. So again, the zinc is going to be a Zn +2. It's going to be added to the nitrate, which is NO3 -1. We crisscross down. We end up with Zn NO3 2, aqueous, and copper metal, which is a solid. So I'll bring this zinc down below so that's all in the same line. So this right here will be your answer for number 4 on that assignment. Number 7, solid manganese 2 iodide. So we have manganese, which is Mn, not Mg. It's going to be a +2. They're telling us what charge to use. Iodide is going to be a -1, and we're going to crisscross those down. So we end up with Mn I2. It's solid. It says that is decomposing when exposed to light. It forms manganese metal, which is going to be MnS, and iodine gas. Iodine is a diatomic, so you would have to have that 2 there. All right, for the final question here, we're looking at number 10. We have iron metal, so that's going to be Fe with a solid. We're adding chlorine gas, which is another diatomic, and we're creating iron 3 chloride. So I'm going to do the work up here. We have Fe with a +3 charge, chlorine with a -1 charge. I'm going to crisscross those down. So that's going to be FeCl3, and that is a solid. So that covers a review for the skeleton equation practice assignments. Next up, we have Unit 8 Notes Part 2. There's only one question on here that was, fairly commonly missed, and it was number 1. In example 1, which element was not balanced in the initial equation? So if I look here, I have 1 carbon on the left, 1 carbon on the right, 2 oxygens on the left, 1 on the right. So the one that is not balanced is going to be the oxygen. That's the one that we had to fix. All right, next we have 8.3, which was balancing practice number 1. Overall, the scores on the balancing practice assignments were pretty good. So if you have any issues with these, just let me know after. But overall, it looks like the class is picking up the balancing pretty quickly. For this one, what you want to do is put a line down the middle. We're going to count each of these elements separately since the polyatomic ion of NH4 is not present on the right, and NO2 is not present on the right either. So we're going to break this down into an N, an H, and an O. I typically put them in the same order on both sides. On this left side, I have N equals 2 because they're in two different places. H is 4, O is 2. On this side, N is 2, H is 2, O is 1. So it looks like I need more oxygens and more hydrogens. If I put a 2 out in front of this, 2 times 2 is going to give me 4 hydrogens, so that actually fixes that part. And then 2 times 1 is going to give me 2 of the oxygens as well. And just putting that one coefficient here actually fixes everything. Now, for our purposes in this class, instead of leaving these blank, which is how you would typically see it, I want you to include ones here. So what you would have typed into Quia is 1, 1, 2. That just lets me know that you didn't skip those spots. You're confirming that this is balanced. So any spaces that would normally be empty, just fill in a 1 when you're done. On the 8.4 assignment, here we're looking at number 7. My phosphorus on the left is going to be a 1, and my oxygen is going to be a 2. On the right side, my phosphorus is going to be a 2. My oxygen is going to be a 5. All right, now I need to make these oxygens the same number. There's no way that I can make this a 5 or this a 2. So what I'm going to do is make both of these numbers a 10, because I can accomplish that through multiplication. In order to make this oxygen a 10, I would have to put a 2 out in front. That changes my phosphorus to a 4, changes my oxygen to a 10. In order to change the oxygen to a 10 on this side, I would need a 5. So 5 times 2 is going to be 10. In order to make the phosphorus now a 4, I have to put a 4 out in front. Now, if you had started by trying to balance the phosphorus first, you would have ended up with a 2 out in front of this. You would have had a little more back and forth before you eventually got to the right answer. So sometimes you just kind of luck out by picking out the right element to start balancing with. All right, next up we have number 10. This is from the same assignment. We have a sodium, we have a hydrogen, and an oxygen. Now you could also break this up into HOH. I believe there's a Melissa Maribel video where they talk about doing that, and then you can count the hydroxide as a single thing. But I do have the hydrogen over here by itself, so if I try to do that, actually no, it would work because you have hydrogen here by itself and then that hydrogen. But it might be easier to just break it up into the individual elements for this one. We have a sodium, a hydrogen, and an oxygen. Sodium on this side I had 1. Hydrogen I'm going to count as 2, so I'm not going to break it up this way. I'm just going to keep it as H2 and O. And then 1 oxygen. On this side I have a single sodium. I have 3 hydrogens because it's in 2 different places. And then I have 1 of the oxygen. I think I wrote this wrong before. That's 1. So I have a 1, 2, 1, and a 1, 3, 1. All right, so I need to balance the hydrogens. On this side, it is an odd number. The only way that I could balance that out is to start by putting a 2 here. That changes the sodiums to a 2. Changes my hydrogens. They are now 2 times 1 plus the 2 from over there. So it's now 4, not 6. Also changes my oxygens to a 2. Okay, now in order to balance this the rest of the way, I could put a 2 out in front of this. That changes my oxygens to a 2, my hydrogens to a 4. And by putting a 2 out in front of this, that fixes my sodiums. So when you're typing this one into Quia, it would be 2, 2, 2, 1. This one would be 4, 5, 2. For this question from Unit 8.5, Balancing Practice number 3, we are going to split this up. We have a potassium on the left, manganese, and an oxygen. Here we have a potassium, a manganese, and an oxygen. Potassium is 1, manganese is 1, oxygen is 4. Over here, potassium is 2, manganese is 1, and oxygen is actually in 3 different places. So we have 1 plus 1 plus 2, which is going to be a total of 4. So currently the only thing that we need to fix is going to be the potassium. All right, so in order to balance this, we can put a 2 over here. So that is going to give us a 2 for the potassium, a 2 for the manganese, and then an 8 for the oxygen. So it doubles each of our subscripts. On the right side, in order to fix this, I can start by putting a 2 here. So that's going to change my manganese to 2. And for my oxygens, it now changes it to 5. Now, currently, this is where you might end up getting stuck. It's really not possible to end up multiplying this to make it an 8. We need to change one of our numbers in order to make this happen, and the easiest way of doing that is by putting a 0.5 in front of this oxygen, which is currently by itself. So if we put this as a 1.5, 1.5 times 2 would be a total of 3, plus the 2 from over there will be 4, 5, plus that one would be 6, so not enough, so not 1.5. Let's try 2.5. If I put a 2.5 here, 2.5 times 2 is 5, plus the 2 from over here is going to be 7, and then plus that 1 would be 8. So what that tells us is that even though these coefficients are not currently allowed, because this ends up being a 0.5, it is the correct ratio. In order to fix this, I can multiply each of these coefficients by 2. So this becomes a 4, a 2, a 4, and then a 5. So you would type in 4, 2, 4, 5. So this will be equivalent to the type of question that you might see in level 3 of the PhET balancing equation lab, if you have already done that. So again, if you run into trouble like this, what you could try is making one of the coefficients a 0.5 temporarily, and then multiplying all of the coefficients by 2 in order to make them all whole numbers again. All right, so this was your commonly missed questions for the week of 413 through 417. If you still have questions about any of our assignments, please let me know either through email or our mailbag.